Okay, good morning, students. Today I'm going to start the new chapter, structural testing, and this is the second of module 3. So, in this chapter, you are going to study about what is structural testing and why we are going for structural testing. Then you are going to study about the types of structural testing techniques, such as testing, branch testing, code testing and the path testing. These are the four condition testing and path testing that you are going to study in this chapter. Okay, so in this chapter you are going to study about what is structural testing, why we are going for structural testing. Then you are going to study about different strategies of structural testing, such as statement testing, branch testing, condition testing, and path testing. In this chapter, path testing you are studying in brief, and there is a separate chapter for path testing is there, that is taken from the textbook one. After completing this chapter, structural testing, I am going to start that particular chapter, that is the path testing. Okay, so first we'll start with the structural testing. Why do we go for, or why do we require the structural testing? And as you know that whenever you are writing the program or the software, that the structure is present in that, right? So structure is present in the program or the software when you are writing that, or when you are implementing a particular system, and that structure is a valuable source of information for selecting the test cases and determining whether those test cases has been sufficient or enough for testing the implemented system or the implemented product. Understood why we are going for the structural testing? Okay, because whenever you are developing a new program or the software or the system, each one is having its own structure, and that structure gives the valuable information for selecting the test cases. Okay, for selecting the test cases, we are using the structure of the system or the program or the software. Okay, so we are using the structure of the system or the program or the software in order to identifying the test cases, because the structure gives the valuable information. And once we select the test cases, then we have to determine whether those test cases are sufficient for testing the implemented system or product. Okay, our implemented system or the software. Hence the structure of the software is which gives the valuable information for determining the test cases. And after determining, or after selecting the test cases, we have to determine whether those test cases are sufficient for testing the developed program or not. And we can, after determining the test cases, so test cases belongs to the test suite. Okay, test suite is nothing but the set which consisting of different test cases. Okay, so once we select the test cases, then we can ask for the test suite whether that test suite has covered a control flow graph or other model of the program. Okay, understood? So once we select the test suite or the test cases, then we can ask whether those test cases or the test suite has covered the control flow diagram or the control flow graph or other model of the program. Other model means it may be the pseudocode, or we can go for any other methods or any other uh, types of the program. So once we use those test cases, we need to determine that whether those test cases are covering the control flow graph or any other model of the program. So in order to get the test suite thoroughness, we are using the structural testing. Understood? So judging the test suite thoroughness based on the structure of the program itself. And when we are judging the thoroughness of the test suite or the test cases based on the structural testing, and this technique is also known as the white box testing, glass box testing, or code based testing. Understood? So here you have already studied in the first module that what are the white box testing, black box testing and all. So here I am not going to explain in detail once again about the black box testing or the white box testing. So we are just comparing the structural testing with the white, whether it is a white box or the black box testing. Okay. So structural testing is a white box testing, and this is also called as a glass box or code based testing. So structural testing is used to judge the test to suit thoroughness. Okay, to test the test to suit thoroughness we are making use of the structural testing, and it is also called as the white box, glass box or code based testing. So in the test or exam, instead of asking the structural testing, they may ask explain the glass box testing or code based testing. Then you have to explain the structural testing. Okay, so structural testing is used to distinguish from the functional based requirements such as the black box testing. Okay, so to differentiate the testing method from the black box testing based on the functional requirements, we are using the structural testing. And structural testing is still the testing product functionality against its specification. Means before the system develops, we are collecting the specifications, right? Based on the specification, we are going to design the system and we are going to implement the system, right? So once again, we are using the structural testing to test the product functionality against the given specification. Then why we are going for the structural based or the code based testing? So suppose whenever you are written the program and when you are executing that program, if part of the program is not executed by any of the test case which is present in the set to suit, then the faults which exist in the program or the system cannot be exposed. Suppose let us consider that you have written the program for the commission problem. Commission problem, you know, right? Commission problem we discussed in the second module. Let us consider the same example. Suppose for the commission problem, you have written the code or you have written the program, and you want to execute that program. After executing, then how you are testing the your developed program? You are testing that by using a test case or the test suite, right? And whenever you are using the different test cases or the test suite, if the program, if any line of the program is not executed by the test cases, then we say that the faults cannot be exposed or all the faults cannot be identified which are present in the program. So basically, if you consider the control flow statement or the combination of the statements or the branches. So your control flow statements, you know, if you're using the if else statement or other branching statements, if one of the branching statement or the if else statement or the for loop statement is not executed, then if faults exist in such statements, then those faults cannot be identified. Understood? Clear? So why we are going for the structural or code based testing? If you are written a program for any problem given and you are executing that program and you are testing the developed program by using the different test cases or the test suite. Even if you are using the different test cases, if one of the statement in the program is not executed, then we cannot assure that the test cases identify all the faults which are present in the program. Understood? So because we in the program is consisting of number of statements or the branch statements or the control flow statements, and there we are also using the different conditions and paths. If one of the condition or the path or if one of the statement is not executed by any test case in the test suite, then we cannot assure that the faults in the program are not are exposed. Okay, hence we are going for the structural or the code based testing. And the complements of functional testing is another way to recognize the cases that are treated differently. So if you're using the switch case statement in the program, then we have different cases exist, right? And to identify those cases, we are going to make use of the structural testing, and structural testing is the complements of the functional testing. Let us consider this example. Here, one program is written for translating a string from the CGI encoding to plain ASCII text. Means what is the input? Input is you're entering any string, and that is converted into the plain ASCII text, right? So in this program, if fault exists, then those faults should be identified when you are executing with the or when you are using the test cases or the test suite. That is the condition, okay? Whether it may be the structural testing or functional testing, or if you consider any type of testing, whenever we are using the different testing techniques, those techniques obviously consisting of the set of test cases or the test suite, okay? And our aim is whenever we are using those test cases and we are testing the program, all the test cases should execute all the statements in the program. And it is very important that if faults exist in the program, those faults should also be identified whenever we are executing the program with the help of the test cases. That is our main aim. So testing is mainly for identifying the faults or identifying the errors. So how to identify the faults or identify the errors? With the help of the test suites or the test cases, right? So if the test, when you're executing the program and you're applying the test cases, if one of the statement is not executed, let us consider that one statement is there while e pointer. So if that condition is not executed, or if that statement is not executed, then we cannot assure that the faults are exposed in the program or exposed from the program. We cannot assure that, because why? The one of the statement in the program is not executed. If this program itself consisting of a fault or the error, then if that is not executed, then that error or the fault which is present in the line 16 cannot be identified. Understood? Like this, we can have many examples. Here they are given with the star. You can see these statements, right? Statement 15, that is int k is equal to 0, or while e pointer, or c is equal to star e pointer, etc. And one more is that at line 20 for c is equal to plus or star dot star d pointer, etc. These are the examples they have given. If these are not executed, if any one of the statement like this, they have given many statements, like if one of the statement is not executed, then if the fault exists in that, that cannot be what identified, right? Then what happens? The Even if the error exists, if that statement is not executed, then the program, if other lines are correct, then the program will be executed, and it gives the output, right? But we cannot say that it is giving the correct output or not, because some of the statements which are present in the program are not fully executed. Understood? Any doubt in this? One more is there right now. Any doubt? Yes, Suraj, Gaurav.
No, ma'am.
Okay.
No, ma'am.
One more example, if we consider here. So here, what is the main program? The aim of this program is to encode the string into the plain ASCII text, right? Means you are converting the string into the ASCII text. In that, we are using the hexadecimal value. See here at line number 31, d pointer is equal to 16 star digit I plus digit low. So here, whatever the value we are getting, that is multiplied by the 16, because we are converting that into the hexadecimal value. Right. So suppose in this program, in this statement, erroneously, if I type this one as instead of 16, if I type this as 6, okay, please see this line. at line number 31, this statement is there. Star D pointer DPTR is equal to 16 star digit I plus digit low. So here, whatever the value we are getting from digit I plus digit low, that is multiplied by 16. Clear? If this is multiplied by 16, that means we are getting the hexadecimal value. Suppose instead of 16, if erroneously I typed it as 6, okay, erroneously if I typed it as 6, what happens to the program? What happens to the program? The program will be executed because no errors in that statement, right? No error in the statement or no syntactic errors. But what happens? I'm not going to get the correct output. Why? Instead of multiplying by 16, I'm just going to multiply by just 6. Then what happens? No doubt I will get the output. The program will be executed and I'm going to get the output. But the output, whatever I'm getting is the wrong output. Why? Because instead of multiplying it by 16, I'm going to multiply it by 8, just 6. So this type of errors exist. So we should be careful whenever we are writing the code. Or suppose if erroneously I am typing this instead of 16, if I typing it as just 1, okay, instead of typing it as 16, or if I just type it as 1, then what happens? The program will be executed and I'm going to get the output, but that output is not correct. Understood? So hence, whenever you are typing the code, you should be very careful about typing the digits. See here, so 16 into, okay, so here no problem, we are getting the output, but the output is not correct. Understood? Clear? So like this, so many, there is a chance that we can have many lines that can be executed. We are getting the output, but that output may not be correct. ಸರ್ ಕ್ಲಾಸ್ ಇದೆ ಆಮೇಲೆ ಮಾಡ್ತೀನಿ ಸರ್. ಓಕೆ ಓಕೆ ಸರಿ ಸರ್ ಆಯ್ತು. ಓಕೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಒನ್? ಎನಿ ಡೌಟ್?
No, ma'am.
Okay. In this example, you have studied so what the problem arises if some of the statements are not executed, and if some of the statements, if we erroneously type this one as instead of 16, we typed it as 6, or instead of 16, we typed it as 1, then we'll get the output, but the output will not be the correct output. Okay. So, and these type of errors that we are going to study in this chapter by considering the different testing strategies, such as the statement testing, then branch testing, then you're going to study about the condition testing and the path testing. Okay. In this, we have one more example. Let us consider in line number 26. 26 is missed out here. Just a minute. In 25. So in line number 25, this is the erroneous statement, but because it contains a fault, because the E pointer which is used to index the input string is incremented by twice. See here, int digit low is equal to hexadecimal values of plus means incrementing twice. So because without checking the size of the string, we are incrementing it by twice. Suppose the string is less than 8 bits, then what happens? Incrementing it by twice will give the wrong result. Okay, so hence first, before incrementing this value by twice, we have to check the length of the string. If the length of the string is greater than 10 or greater than 16, we can make use of the plus, means we can increment it by twice. Otherwise, it is not possible. So hence, before incrementing it, we have to check the size of the string or the length of the string. That is one example. Okay, so here we are having the control flow graph for the function that is a CGI decode. So CGI decode is that we are using here. It is a CGI encoding program, and here also we have the CGI decoded. Wait just a minute. This program widely pointer is this is the example that this example we'll discuss in the next class, because for this before discussing this example you need to know what is a statement testing, branch testing and the code testing. So that we are going to study in the next class. ನನಗೆ ಬೇರೆ ಕೆಲಸ ಇದೆ so this is about the structural testing, why we are going for the structural testing and what problem arises when one or many of the statements are not executed by the test suite or the test cases.